Today we are going to do definite integrals. First I'll explain the properties and then I'll attempt the questions. So first property is that if I have the limits a to b fx dx, I can change the perimeter, which I can write as fy dy, ft dt, whatever. Why? Because after we put the limits, it's only a number. It's not in x, y, or t. It's only a number. So I can write any variable over there. Second property is if I interchange the limits, if it is a to b fx dx, I can put minus over here and I can interchange the limits. Means upper will become lower, lower will become upper, and the minus will come out. Right? Then, if I do have a to b fx dx and c is any point, c is any value lying in a and b, then I can write it as a to c fx dx plus c to b fx dx. This is the third property. Then fourth property is I have a to b fx dx. I can use the property of a to b f of a plus b minus x dx. This is what? Lower limit plus upper limit minus x dx. Wherever x is there, you will replace that by a plus b minus x. Right? If you want the proof of this, let us take a plus b minus x is equal to t. So when x is equal to a, then t is equal to b. And when x is equal to b, then t is equal to a. So I am getting minus dx is equal to dt, or dt is equal to minus dx now. So I'll get minus of ft dt, and the limit is b to a, which is what? If you use the second property, what is that? That if minus is there, I can interchange the limit. So can I write this as a to b ft dt? Using the first property, what did I say? That whatever is the parameter, this variable, I can use x because finally it's a number, so I can write a to b fx dx. So this is the way we can prove it. Why I am telling you? Because once in the board exam it has come, and then the question was to be proved, hence use this to prove. So that's why I am telling you this. Prove. Again, listen to this. What is the property? It's up lower a to upper limit b fx dx is equal to a to b. Take lower limit plus upper limit minus x dx. You can use this property. I will let you know when to use this. Then what have we taken? A plus b minus x is equal to t. So minus dx, this is substitution method. Minus dx is equal to dt. So when x is equal to a, so a and a will get cancelled now. So t is equal to b. And when x is equal to b, so this b and b will get cancelled. So x is equal t is equal to a. So I can write this limit as this, right now, minus b to a ft dt. Minus is used to interchange the limit. So it has become a to b ft dt, and then parameter variable is changed. Clear? Then the next property is the part of this only. This is 0 to a f of x dx. So can I use the same? 0 to a f of 0 plus a minus x. 0 is no need to write. The proof is same. You can apply the same proof for this also. Next one is 0 to 2a fx dx. I can write this as 0 to a fx dx plus 0 to a f of 2a minus x dx. Clear? This is just breaking the limit in 0 to a, 0 to a, and using this. First, it is fx same only, and then 2a minus x. The next property is 0 to 2a fx dx, that is equal to 0 if f of 2a minus x is equal to minus f of x. Means if I put 2a minus x in the function and you are getting minus outside common, then it is 0. We can call it as odd function also. And if it is f of 2a minus x is equal to fx, then it will be twice of 0 to a fx dx. Means limit will be half and it will be twice of it. Clear? Same result we will use for minus a to a fx dx. So if f of minus x is equal to minus f of x, then it is odd function. So this will be 0. And twice of 0 to a fx dx. When f of minus x is f of x. Right? Example, if I take sine of minus x, that is minus sine x now, so this is odd function. Tan also odd function. But if I take cos of minus x, that is cos x, so that will be even function. So in this case, you will be doing this, and in this case, you will be doing 0. Clear? Same, this is for pi minus x, cos will be negative, so that is odd function. But for because pi I can write as 2 into pi by 2, no? And pi minus x for sine is even function. So same will be there. Then next property is this is only all the properties. Again, listen to this. What is the first property? I can change the variable x, t, what, y. If limits are same, then I can change the variable, because after putting the limit, it's a number, not the variable. Then if I interchange the limits, then minus will come out. Then if I am taking, suppose this is 0 to pi, I can take 0 to pi by 2 and pi by 2 to pi. Clear? This type of a to c, c to b. Then next one, if this is a to b fx dx, what are we writing? F of a plus b minus x. This property is used when it is pi by 6 to pi by 3. If you add them, this is 30, this is 60. 30 plus 60, 90 now. So mostly in that case, we use this property a plus b minus x. When lower limit is pi by 6 means 30 and upper limit is pi by 3 when means 60. Most of the time we use this property. Then next one is 0 to a fx dx, that is equal to 0 to a f of a minus x. Upon this property only, because here it is one value is 0, so it is upper limit is added. And then 0 to 2a, 0 to a fx dx and 0 to a f of 2a minus x. This property, I told you, suppose it is 2 pi minus x. 2 pi minus x for cos is even, na? And for sine it is odd. So we are using this when it is odd. Minus is coming out because sine of 2 pi minus x is minus sine x. So in this case, it will be 0. But in cos, it will be twice of 0 to a means limit will be within 0 to pi cos x dx. Clear? And in sine case, it will be 0. And here also I have given in the example. Clear? So properties are clear. Let us go to the exercise. First question is, in these definite questions, property 1, always try to take it as I. Always take, not try. Always take this as, so this is 0 to pi by 2 cos square x. So in the trigonometric integration, what have you done? You have written cos square x as 1 plus cos 2x by 2, no? And then you have integrate. But here, what will we do? We will put the limit 0 to pi by 2. cos square pi by 2 minus x. What is cos pi by 2 minus x? Sin x, na? So this will become 0 to pi by 2 sin square pi x dx. This is also y. What will I do? I'll label this as 1, this as 2. So 1 plus 2 will give you 2i, that is equal to 0 to pi by 2 cos square x plus sin square x dx. So that is 1 now. So this is 0 to pi by 2, 1 dx, which is equal to x. Limit is 0 to pi by 2. So what are you getting? Pi by 2 now? 2i is equal to pi by 2. So I is pi by 2. Clear? Understood? When to use this a minus x wala property 0 to a. That property we have used. Then second question. I is equal to 0 to pi by 2 root sin x upon sin x plus cos x. Use a minus x property only. So this will be 0 to pi by 2 sin pi by 2 minus x. Denominator sin pi by 2 minus x plus cos pi by 2 minus x, right? What will be that? 0 to pi by 2, it will become cos x. Similarly, denominator, this is cos x, this is sin x, right? If you check, isn't the denominator of first and second is same? Denominator sin x plus cos x, sin x plus cos x. So if I take the LCM of 1 and 2, what will be that? If I take the LCM of 1 and 2, what will be there? Take this as I also. So add 1 and 2. 1 plus 2. What will be that? 2i is equal to 0 to pi by 2. Sin x upon sin x plus cos x. Same here. Cos x upon sin x plus cos x dx. So isn't it coming 0 to pi by 2 sin x plus cos x upon sin x plus cos x dx. So 1. So 0 to pi by 2 dx, that is equal to x, which upper limit 0 to pi by 2. So it is coming pi by 2. So R2i is equal to pi by 2. So I is pi by 4 now. Clear? So please try third question, fourth question by this method. Clear? Even you can do 17th question with this method. Which one? First, second, third, fourth, and 17th. Here also it will become a minus x. And this will become a minus x. This will become x. So denominator will remain same. Na? So if you add, it will become 1. So you can try these questions by yourself. Same property. Next question I am going to do is question number 5. Question number 5 is minus 5 to 5 x plus 2 mod d. So mode, what is the mode definition? What is the mode definition? If you take the number line, at what number, what value of x it will be 0? Minus 2 now. So to the left of the minus 2 it is negative, and to the right of minus 2 it is positive. So minus of x plus 2 when x is less than minus 2, and x plus 2 when x is greater than or equal to minus 2. The limit is from minus 5. Minus 5 is on the left now, and 5 is on the right. Clear? So what will you do? Minus 5 to minus 2. It is minus of x plus 2. Clear? And from minus 2 to 5 it is plus. So minus 2 to 5, it is x plus 2 positive. Just integrate like previous definite integral, it will be minus x square by 2 plus 2x. Put the lower limit and upper limit, and this will be x square by 2 plus 2x. Put upper limit and lower limit. Clear? I hope this is understood. Then next question. Sixth question. What will be the breakpoint for this? 5, na? At 5. 5 minus 5, it is 0. So 5 is this. The left is negative, right is positive. 2 is this side and 8 is this side. So what will you write? 2 to 5 minus of x minus 5 and 5 to 8 plus of x minus 5. Clear? 2 to 5 minus of x minus 5 and 5 to 8 x minus 5. Positive. Integrate this. Clear? Next one. This is the property of seventh question. Same a minus x property. Seventh question is I is equal to 0 to 1 x 1 minus xn. Now you will ask me when to use this property. Remember, if I want to use open this bracket, is it possible? If the square, then you can open. If cube, just still you can open. But if it is more than 3, then you have to multiply and all that. So when to use? When you have the higher power and you are not able to do it by parts or whatever you can say. So what will I do? 0 to 1, 1 minus x, a minus x. And here it will be 1 minus x, a minus x is replaced by a minus x, right now? So this is equal to 0 to 1, 1 minus x. And here it is 1 minus 1, 1 minus 1 plus x raised to power n dx. So 1 and 1 cancel. So what I am getting? 0 to 1, 1 minus x, xn. Now can I open the bracket easily? 0 to 1, xn minus xn plus 1 dx. Now isn't it easy to integrate? This will be xn plus 1 upon n plus 1. And this will be xn plus 2 upon n plus 2. Put the limit 0 to 1. So this is 0, it will be 0 only, so 1 upon n plus 1 minus 1 upon n plus 1. Clear? Now, next one, you can use this property in question number 9. Try this one. Question number 9, you will use this property. Clear? Next, come to question number 8. 9, you will try by yourself. Question number 8. I is equal to 0 to pi by 4 log of 1 plus 10x dx. So use a minus x only. So 0 to pi by 4 log of 1 plus 10 pi by 4 minus x. A minus x, no, x is replaced by this. Okay. So if you use this 0 to pi by 4 log of 1 plus 10 pi by 4 minus x is 1 minus 10x upon 1 plus 10x. Identity of 10a minus b. 10a minus 10b upon 1 plus 10a 10b. Or directly if you know, then very good. So this is 0 to pi by 4 log, take the LCM 1 plus 10x plus 1 minus 10x upon 1 plus 10x. LCM is taken in between the bracket. So 10x is cancelled. So what I am getting? 0 to pi by 4 log 2 by 1 plus 10x. So log property, log x by y is log x minus log y now. This is I. So log of x by y, that is equal to log x minus log y. Use that property, so it will become 0 to pi by 2 log 2 dx minus 0 to pi by 2 log of 1 plus tan x dx, right? Isn't it I, the question given? And this side is also I. So if I bring it to this side, left side, it will be 2I. That is equal to 0 to pi by 2 log 2. Log 2 is a constant. So log 2 will be out and the one differentiation, sorry, integration will be x. And limit is what? 0 to pi by 2. So what is the answer? Pi by 2 log 2. That is equal to I. So I will be equal to pi by 4 log. Clear? What? How did we do? Just replace x by a minus x, which is pi by 4 minus x, right? Then tan a minus b is tan a minus tan b upon 1 plus tan a tan b. And tan pi by 4 is 1. So better to remember tan pi by 4 property. If it is a minus up, it will be minus up. If it is plus here, it will be plus up in the numerator. So tan pi by 4 minus x is 1 minus tan x upon 1 plus tan x. Take the LCM. So this will be 1 plus tan x plus 1 minus tan x upon 1 plus tan x. Tan x cancel. 1 plus 1, 2 upon this. Use the formula log x by y property of log x minus log y. So this minus this. So log 2 minus log 1 plus tan x, which is the original question, which is if we have taken as I. So I plus I will become 2I, which is equal to log 2. Log 2 is constant. One, the integration is x. X limit, if you will put pi by 2, so log 2 pi by 2. 2 will come this side, so pi by 4 log 2. This is the answer of this question. Clear? 9th, you will try by yourself. Now come to question number 10. Question number 10. 0 to pi by 2 taken as I. Can I write this as log sine square x upon sine 2x? Same property. Log, this is first. This property is n log x. So that is equal to log x raised to power n. No? This power, this goes in the power of this, right now? So this is 2 is taken as sine square. And then just in previous question we have used log x by y is log x minus log y. So this will become in the denominator. So 0 to pi by 2 log sine square x upon 2 sine x cos x. So one power is gone. Dx. So this is 0 to pi by 2 log for tan x by 2. Right now? Sine by cos. So this is 0 to pi by 2 log tan x minus log 2 0 to pi by 2 dx. Right? Now if I take log tan x separately, I want to check. I want to solve this as I1. I1 is 0 to pi by 2 log tan x. Use the property of a minus x, that is 0 to pi by 2 log tan minus pi, tan pi by 2 minus x. No? That is cot x. 0 to pi by 2 log cot x. That is equal to I, adding 1 and 2. This is you have to solve separately. So 2I is equal to 0 to pi by 2 log tan x plus log cot x. So we know the property log x plus log y is log xy. No? So that property if we use, it will become log tan x cot x dx. Tan and cot 1 now, because cot is 1 by 10. So this is 0 to pi by 2 log 1. Log 1 is 0. So isn't I1 is coming 0? So this I1 is equal to 0. So from you can give this as 3, this as 4. So from 3 and 4, what are you getting? This value is 0. So you are just left with I is equal to, you are just left, I is equal to 0 to pi by 2 minus log 2 dx. Log 2 is constant, take it out. So minus log 2, 0 to pi by 2 dx, which is equal to x. So value, if you will upper value, you will put that will be pi by 2. So this is the answer. Again, see what we did. What did we do? In this question, first property of logs are used. N log x is always log xn. Remember, this is on this, not on this. Power is coming on x, not on proper full log x. So log xn. That sine square upon sine 2x, because minus comes in the log denominator. So sine square is sine 2x is taken as 2 sine x cos x. 1 sine x cancel, sine by cos is tan x by 2. If again use the property of log x by y is log x minus log y. Now take this 0 to pi by 2 log tan x separately, and I1. Now use the property again, pi by 2 minus x. So this has become cot x. If you add I1 with I1 means 1 plus 2. Like previous question we are doing. So this is 2I1 is equal to log tan x plus cot x. So log x plus log y is log xy multiplying. So log tan x cot x, which is 1. Log 1 is 0. So this value is coming 0. Put in the original equation. Main question. This value is 0. So this value is x. X value, if you will put pi by 2 upper limit, so this is coming minus pi by 2 log. Clear? Next question, 11. Eleventh question is I is equal to minus pi by 2 to pi by 2 sine square x dx. Now, if I put sine square minus x, what is that? Sine square x, no? So isn't it even function? So if we use the property even function wala, f of minus x is equal to fx, what do we use to do? Twice of 0 to a, right? So it will become minus a to a will become twice of, not so twice of 0 to pi by 2 sine square x. So isn't it your same question as first? What is that? Put pi by 2. So 2, 0 to pi by 2 sine square pi by 2 minus x dx. That is cos square, no? So this is 0 to pi by 2 cos square x dx. So if you add 1 and 2, this is your 1, this is your 2. If you add 1 and 2, so this will be 2y is equal to 2 common, 0 to pi by 2 sine square x plus cos square x, which is equal to 1. And this 2 and 2 cancel. So I is equal to 1 dx, which is equal to x. So if we put upper limit, that will be power. Clear? Next, in this 13th question, if I put sine of minus x, this will be minus sine x now. So this is odd function, directly 0. Understood the difference between these two when it is even function, when it is odd function? If you put sine of minus x, here it is becoming plus. So I have taken twice of this 0 to pi by 2. But here if you put power is odd, na? Power is odd. So this is coming. Here the power is even. Here the power is odd. So this is odd function. Odd function directly 0. Clear? Now come to question number 12. just hold on. So next question number 12. I is equal to 0 to pi x dx upon 1 plus sin x. Put the property a minus x. 0 to pi minus x dx upon 1 plus sin pi minus x. Clear? So this is 0 to pi minus x dx upon 1 plus sin x only, because 180 minus x, sin is positive now. So this is same. So can I separate this? This will be 0 to pi upon 1 plus sin x dx. Numerator I am separating. 0 to pi minus is taken out, x dx upon 1 plus sin x. So isn't it the given question? So if I transpose it to the left, what will I get? I plus I, 2i. That is equal to 0 to pi. Pi will come out dx upon 1 plus sin x. Now, 1 plus sin x, how have you solved earlier? Pi. 0 to pi. If you multiply this by 1 minus sin x in the numerator and denominator, it will be 1 minus sin square x. 1 plus sin x, 1 minus sin x. So that will be 0 to pi cos square x. So 1 by cos square x minus sin x by cos square x. Right? Because this 1 minus sin square x is cos square x. So 1 upon cos square x upon minus sin x by cos square x. Now 1 by cos square x is sec square x, whose integration is tan x, right? So this is pi 0 to pi sec square x dx minus 0 to pi tan x sec x. Both integration, you know, this is tan x integration and this is sec x integration. So put the values after that. Tan x is 0 in both the cases at 0 and pi. Na? Tan 0 is 0, tan pi is 0. So this value will give you 0. And here sec pi is minus 1 and sec 0 is 1. Clear? So this is the question. Next question is the 13th I have already told you. Now 14th question. 14th question is 0 to 2 pi cos 5x dx. Right? So if I put f of 2a minus x, so that will be 2 pi minus x. That will be cos 5. Cos 5, 2 pi minus x. 2 pi minus x means fourth quadrant in which cos is positive. So this is even function. Now, so what can I write? Twice of 0 to pi cos 5x. Right? Again use this property. Can I write 2 into pi by 2 now? So 0, 2 into pi by 2. Cos 5x dx. Right? So again, f of pi minus x. So that will be cos of pi minus x. That is minus cos x, and power is also odd. So isn't it odd function? So if it is odd function, value is 0. This answer is 0. Clear? Now question number 15. Put pi by 2. This will become cos this will become sine, and denominator will remain same na. It will become 1 plus cos x sin x. So if you add then that will become 2y is equal to sin x minus cos x plus cos x minus sin x. So all values will get cancelled in the numerator and the answer will be 0. Clear? Again listen to this. What will you do? You will put sin pi by 2 minus x. So this will get cos x. This cos pi by 2 minus x is sin x. So if I add the numerator, it will be sin x minus cos x plus cos x minus sin x. Check. Cos x cancel with cos x, sin x cancel with sin x. Denominator is always 1 plus sin x cos x. That is equal to 2y, no? 0 upon anything is 0. So answer is 0. Clear? So 17th I have told you put a minus x. The denominator will become same, and if you add 2y is equal to this, get cancelled numerator and denominator. Here in this question, 18th question, 0 to 4 x minus 1 dx. This is your line. 1, 0 is this side and 4 is this side, right? So here it is negative, here it is positive. So what will you do? 0 to 1 minus of x minus 1 and 1 to 4 x minus 1 dx. Clear? So this is the question. Now this question number, for doing this question number 6, I need to explain you the example of log sin x. What is that? If you check the last example of this exercise in your NCERT book, that is 0 to pi by 2 log sin x. So what will we do? First we will put the property. 0 to pi by 2 log sin pi by 2 minus x will be cos x, no? Understood now? If I put pi by 2